Imagine being present at the birth of a star, witnessing the first spark in the cold vastness of space. Where does this luminous journey begin? In the heart of a nebula, a vast cloud of gas and dust suspended in the cosmos. Nebulae serve as the stellar nurseries of the universe. Within these clouds, particles collide and stick together, gradually building up a mass under the force of gravity. As the mass grows, so does the gravitational pull, attracting more particles at an accelerating rate. This process, a captivating dance of creation, forms what we call a protostar. The protostar stage is a turbulent one. The core temperature rises dramatically as the protostar contracts under gravity. When the core's temperature reaches about 10 million degrees Fahrenheit, nuclear fusion ignites. This marks the birth of a star, transforming hydrogen into helium and releasing immense energy that pushes against gravity, establishing a delicate balance. Now, our star enters the main sequence phase, the longest period of its life. During this stable era, the star continues to fuse hydrogen into helium in its core. For a star like the Sun, this phase can last about 10 billion years. However, the story changes dramatically as the hydrogen supply dwindles. As the hydrogen runs out, the star's core contracts and heats up, expanding the outer layers and transforming the star into a red giant. This bloated star phase sees the core reaching temperatures high enough to fuse helium into heavier elements like carbon and oxygen. But even stars cannot escape mortality. What follows is determined by the star's mass. Smaller stars, like our Sun, gently shed their outer layers, creating a beautifully intricate nebula, while the core becomes a white dwarf, slowly cooling over billions of years. More massive stars meet a more dramatic end. Upon exhausting their nuclear fuel, their core collapses under gravity, resulting in a cataclysmic explosion known as a supernova. This spectacular event scatters newly formed elements across the galaxy, elements that can one day become part of new planets or even life itself. Thus concludes the epic saga of a star's life, from a mere cloud of dust to a key player in the cosmic cycle of creation and destruction. Each stage of a star's life not only illuminates the universe but also contributes to the cosmic alchemy that is essential for the emergence of life. Every atom in our bodies was once part of a star that exploded, linking us indelibly to these celestial giants.